This is part 2 of my rebuild of a Bridgeport M-Head milling machine. If you've missed part 1, there's a link below. There are chapter markers below if you want to skip ahead to any of these particular sections. And there are links in the information section below the video for access to these documents, which may prove helpful. After spending many hours hand scraping 56 years of wear out of the base, knee, saddle, and table, I would hate to wear them down prematurely. I always wanted a one-shot lube system, but after purchasing the manual lubricator and starting to look into all of the additional parts I would need, I started getting cold feet. When I moved from Massachusetts to Arizona, the one-shot lube project went on hold for over a year. When I finished my work on the saddle, I couldn't bring myself to assemble it without a one-shot lube system. Here is how I did it. Buying the parts. I started by calling Bijur, B-I-J-U-R, and found out that the Bridgeport 9-point kit, part number K-1099, cost $469. After a little sticker shock, I asked the price of just the manual lubricator. Wow, that was only $212. Wow again. I also tried High Quality Tools Incorporated. They are available on the web at hqtinc.com. They have an excellent catalog that has a small diagram of the lube system available from Lube USA. You have to order from High Quality Tools through a distributor. I have ordered through Rice Machinery, and their website is www.ricemachinery, that's RICEMACHINERY.com. In the past, experts at Rice Machinery answered my technical questions, but even Rice Machinery wanted $233.75 for the Bijur manual lubricator. So I purchased my Bijur manual lubricator from Inco for $76. Unfortunately, Inco is out of business, but I have seen these Bijur manual lubricators on eBay for about $65. After watching the web and trying local hardware stores, I finally determined it was possible to save some money, but it was not going to be a nickel and dime deal. One cost that stayed high was the meter units. Bijur wanted $9.88 to $17.63 for the meter units specified in their kit, number K1099. Another vendor, Trico, T-R-I-C-O, is listed in the MSC catalog, but their meter units were approximately $10 each. Trico's website is tricocorp.com. Lube USA had the most economical units from $7.29 to $13.09, so I ordered all my plumbing and meters from them. Lube USA has merged with Lube Corporation, which is headquartered in Tokyo, Japan. Their website, www.lubeusa, that's L-U-B-E-U-S-A.com, will actually link to a place that'll give you the similar results to what I got years ago. They were very professional and didn't seem to mind a small order from an individual. They also have an excellent catalog. If you ask, they will send you a one-page Bridgeport milling machine 9-point lubrication system diagram that lists most of the part numbers you need to retrofit an existing Bridgeport. I have a list of all of the items that I bought at Lube USA. I'll include that list in the description below the video, and include the simplified diagram showing how the lube system is hooked up to a Bridgeport. The new Bridgeports have 12 inches of Y travel, where mine has 9 inches of travel. I measured a new Bridgeport mill, and the lubricator was approximately 10 1/4 inches down from the top of the knee to the top of the lubricator, and 4 1/2 inches from the back of the knee to the back of the lubricator. Because my knee is smaller, I place my lubricator 7 1/4 inches down from the top of the knee and 4 1/4 inches from the back. I mounted all of my hardware on the knee by drilling and tapping 1/4 by 20 holes. I also measured and stared at the flexible hose for quite a long time before I decided that I did not need the 14-inch flexible hose, but instead ordered a 12-inch hose. The junction should be located as close to the knee as possible because the tubing must make a sharp bend through the new drilled hole and reamed out 3/4 of an inch into the top of the saddle. I wish I had positioned mine about 1/4 of an inch closer to the saddle. Instead of running the lines to the old Zerk holes, I cross-drilled into the existing oil paths and installed the drive barbs. They were actually hammered in, elbow connectors. To make sure I didn't miss the existing oil passageways, I inserted brass rods through the old Zerk holes and made sure that my measurements agreed with the line of sight observations. I asked a fellow at Lube USA what size hole to drill for the drive barbs. He suggested 1/8 inch. That is correct for the barb, but I drilled a couple sizes smaller and worked my way out to 1/8 inch. To drill in the sides of the saddle, I had to use a 90-degree drill adapter and the screw machine stubby drill bits. I just barely had enough room. If you don't have a screw machine drill bit, you could easily just grind off the end of a cheap bit and make one. One of the critical holes ended up just a little too large. I could have ordered the next size larger barb, but instead I put a layer of solder on the old one and then fit it tightly. This photo shows the 5/32 inch tubing with a compression nut, 4mm tubing insert, and a 4mm compression sleeve. The flow units coming out of the manifolds come in a couple of different sizes to determine how much oil flows through. The number 0 meters put out a certain amount of fluid. The number 1 meter puts out twice as much. I put the small number 0 meters on the vertical ways and on the cross-feed Acme screw. Now the cross-feed screw gets about 7 drops of oil per cycle. The vertical ways get the biggest mess, so I'm glad that I only put the number 0 meters in them. Since they are not under pressure from the weight of the table and because the knee moves less frequently, they require less oil. To get oil to the feed screws, there's a hole on the top of the feed nut bracket. Normally, you would center the table with a mark on the saddle, remove a set screw in the middle of the table, and drip some oil through the hole. I used Bondo to fasten the 5/32 inch nylon tubing to the top of the feed nut bracket. Bondo was my second method of fastening. My first was not successful. After fastening the tubing to the bracket, I got to thinking it might not clear the bottom of the table. In the photo above, I set up some 1, 2, 3 blocks and measured the depth across the entire bottom of the table. It was just a hair more than 5/32 of an inch. In hindsight, I should have ground a groove in the feed nut bracket with a Dremel tool and laid the tubing in it to have more free space. In my case, I elected to modify the original plans from the list from Lube USA, their 9-point lubrication systems, for 3 reasons. 1, I had an older mill with only 4 oil Zerk fittings on the saddle. 2, I wanted to keep it clean so that adding a power X drive and limit switches wouldn't have me cursing the plumbing job, so I eliminated the outside plumbing on the saddle. And 3, I had the saddle completely apart and it would never be easier. Instead of the 6-port junction mounted under the saddle, I had a 5-port junction. Note that even though it is called a 5-port junction, there are actually 6 outlets, 5 to the side and 1 out the end where I installed a plug. If I had a chance to do it over again, I would change the layout on the left side of the knee to more closely match the layout pictured in this old Bridgeport manual. Also, I would have used brass tubing, even though it would have been a bit harder to work with. There is an advantage to the nylon tubing. It is very reassuring to see the whey lube travel up the clear plastic tubes on all 7 of the lines. There had been a lot of discussion on the internet about the proper oil to use. Some use 30-weight non-detergent motor oil. Some have used chainsaw bar oil. I am using True Edge brand special whey oil number 68. I purchased a gallon of it years ago, long before I ever had a milling machine. However, the consensus is that the best choice is Mobile Vectra number 2 oil. Last but not least, the job isn't done until the Zerk holes are all plugged. I thought I might want to leave them in as an emergency way of supplying lube, but I thought I might want to insert plugs made like set screws for easy removal. Finally, I decided I just wanted the front to look as nice as possible with little evidence of the previous oil holes. I inserted 4 1/8-inch NPT pipe threads, ground off the heads with a Dremel wheel, and filed the stub down flush with the saddle. The backlash in the feed screws was bad. I wasn't too concerned about accuracy because I intended to install a digital readout. However, I just couldn't bear to put it back together without making some attempt to reduce the backlash. The feed nuts are both enclosed in a feed nut bracket. Like all fittings on this Bridgeport, they came out quite simply. This machine had apparently been in a greasy environment all its life. There's an important oil passage on the top of the feed nut bracket through both the longitudinal feed nut and the cross feed nut. You should remove both feed nuts and clean this out thoroughly. There's a slit almost completely through the feed nuts, as shown in this picture. This is the way the nuts come from the Bridgeport factory, and they are installed while they are still in one piece. If you attempt to adjust them, you will just get frustrated. They have to be removed first and cut through the rest of the way with a hacksaw, then reinstall them in the feed nut bracket and adjust out as much backlash as possible. When doing this, make sure you test the full travel of the feed screw because your screw may be more worn at the center than at the ends. If you get it nice and tight in the center, it will bind when you traverse the table towards the end. I wish I had split the feed nuts when the table was out, but I didn't. I had the entire table back together before I decided I really wanted to split the nuts. It is possible to remove the feed nut from the feed nut bracket while it is still in place. The above photo shows the view looking at the feed nut bracket through the front of the knee. As always, thanks for watching, and I hope you enjoyed the video.